Here we have a pre-calculus problem on the board. Okay, let's go over the question. The graph of the polynomial function shown below as integral x and y-intercepts. The equation of the function can be written in the form p of x equals to a x to the fourth power positive b x to the third power positive c x to the second power positive dx positive e, where a, b, c, d, e belongs to I, it is integers. In the equation above, the values of a and e are respectively. So our aim is to find the values of a, which is the coefficient of x to the fourth power, and e, the constant term in the given polynomial function p of x. Okay, when I look at the graph of the given polynomial function, I find two x-intercepts, -1 and +2. Okay, now let me find the factors corresponding to these two x-intercepts, -1 and 2. So here we have x equals to -1. To get the factor corresponding to this x-intercept, I just have to make the right side 0. For that, I have to add 1 to both sides. When I do so, I'll be getting x positive 1 equals to 0. So x positive 1 is the factor corresponding to the x-intercept -1. So the same thing I have to for the second x-intercept 2, that is x equals to 2. So let's make the right side 0. For that, I have to subtract 2 from both sides. Positive 2, -2 will cancel out. I get x -2 equals to 0. So the factor corresponding to this x-intercept is x -2. Okay, now I got the two factors corresponding to the two x-intercepts -1 and 2, and these two x positive 1 and x -2 are the factors of the polynomial function p of x, because this is the graph of the polynomial function p of x. Okay, now let's write the given polynomial function p of x in terms of the two factors x positive 1 and x -2. Then we get p of x equals to x positive 1 times x -2. Okay, here at the x-intercept -1, the graph does not cross the x-axis, it just touches the x-axis. So since the graph touches the x-axis at the x-intercept -1, so the multiplicity of this factor x positive 1 must be an even number. Okay, so and also the same thing at the x-intercept 2, the graph touches the x-axis, so the multiplicity of this factor also x minus 2 also must be an even number. So I can take 2 or 4 or 6 as exponent for this factor x positive 1, the same thing for this one. But the degree of the given polynomial function is just 4. So what exponent should I take for this one? But it has to be an even number. So I can take 2 for this one, 2 for this one. So that when I expand this one, I'll be getting x square from the expansion of this one. And from the expansion of this one also, I'll be getting x square. When I multiply them, I'll be getting x to the fourth power. So the degree of the polynomial function will be 4. And also one more thing we have to notice that the given polynomial function, the coefficient of x to the fourth power is a. So I must take a over here. So that a times, I'll be getting x square from this factor, a times x square. And x square, I'm getting x square from this factor. So when I combine all this stuff, a times x square, I'll be getting this a times x to the fourth power. Okay, so now we got the polynomial function from the factors x positive 1 and x -2. So that is p of x equals to a times x positive 1 the whole square times x -2 the whole square. And also whenever we have a polynomial function like this, so here the polynomial function has been defined by p of x. Sometimes it will be defined by f of x, sometimes it will be defined by g of x or h of x, something like that. So whatever stuff we have over here, p of x, f of x or g of x, so actually it is equal to y. So it can be replaced by y. So now let's replace this p of x by y. Then we get y equals to a times x positive 1 the whole square times x -2 the whole square. Okay, so again, when I look at the graph, the y-intercept is 8. Actually, what is the y-intercept in terms of point? So it's 0, 8. So whenever we have y-intercept, the x coordinate will be 0, and the y coordinate is a value on the y-axis at where the graph crosses. Here, so the graph crosses the y-axis at 8. So the y-intercept is 0, 8. Since the graph is passing to the y-intercept 0, 8, I can plug in 0 for x and 8 for y into this equation. So now let me do it. So now I'm going to plug in 8 for y, and a times 0 positive 1 the whole square and 0 -2 the whole square. Then I get 8 equals to a times 0 positive 1 is just 1 square and 0 -2 is -2 the whole square. 8 equals to a times 1 square is 1, -2 the whole square is 4. So 8 is equal to a times 1 is a, and a times 4 is 4a. So I'm getting 4a. So I divide both sides by 4 to solve for a. So this 4 will cancel. 4 goes into 4 one times, 4 goes into 8 twice. So I get 2 equals to a. So the value of a is 2. Okay, now let's rewrite this polynomial with the value of a equals to 2. Then we get p of x equals to So 2 times, for a we can plug into x positive 1 the whole square times x negative 2 the whole square. Okay, so for this polynomial function, so to get the constant of what I need to do is I need to expand this binomial, the square of the binomial x positive 1 whole square and the square of the binomial x negative 2 the whole square. So for that, I can use the algebraic identity, that is a positive b the whole square equals to a square positive 2ab positive b square. And to expand the square of this binomial, I can use the identity algebraic identity a negative b the whole square, which is equals to a square negative 2ab positive b square. Okay, now let me use the identities, the two algebraic identities to get the expansion of the square of the binomials x positive 1 the whole square and x negative 2 the whole square. Okay, let me do it. So p of x equals to 2 times. So this is in the form of a positive b the whole square. So the expansion of a positive b the whole square is a square positive ab positive b square. So the same expansion we can take for this one, but at the place of x we have x, at the place of a we have x, at the place of b we have 1. So we have to replace a by x and b by 1. Let me do it. So x square positive 2x positive 1. So this is x square positive x positive. This is the expansion of x positive on the whole square. And for this one, x negative to the whole square, it is in the form of a negative b the whole square. Instead of a we have x, instead of b we have 2. So we can do x square negative 2 times, for a we have x, for b we have 2 times x times 2 will become 4x, and b square means it's 2 square. So because at the place of b we have 2 over here, so it's just positive 4. Okay, now to get the constant term of this polynomial function, what I need to do is I have to multiply the constant we have in front of the two factors and the constant term of the first factor, the constant term of the second factor. So 2 times 1 times 4. So that gives me the value of 8. So this is a constant term of the polynomial function p of x. But what is a constant term in the given polynomial function? That is e. So at the place of e, we must have 8. So the value of e equals to 8. So already we got the value of a, that is 2. Now I got the value of e, that is 8. So the value of e, a and e are respectively 2 and 8.